Constructing confidence intervals when the population standard deviation is known. Let's try some examples. How much time do Americans spend eating or drinking? Based on a random sample of 1,120 Americans 15 years of age or older, the mean amount of time spent eating or drinking each day is 1.21 hours according to the American Time Use Survey conducted by the Bureau of Labor Statistics. Assuming the population standard deviation for amount of time spent eating or drinking is 0.65 hour, construct and interpret a 90% confidence interval for the mean amount of time spent eating or drinking each day by Americans 15 years of age or older. As you can see, as I read the problem, I highlighted the important facts that we're going to need in order to complete the problem. First, it's important to note that we are dealing with a random sample. Our sample size is n equals 1120. We're given that the sample mean, x bar, equals 1.21 hours. We're told that the population standard deviation, which is sigma, is equal to 0.65 hour. Because of this information, it's a random sample, the sample size is greater than or equal to 30, and we have this population standard deviation. We can use the normal distribution to construct our confidence intervals. Normal distribution. Alright, we're asked to construct a confidence interval based on a 90% level of confidence. The first step is to find the critical value associated with this level of confidence. Z sub alpha over 2 is equal to 1.645. The formula to construct a confidence interval is x bar minus the critical value Z sub alpha over 2 times sigma divided by the square root of n is less than mu is less than x bar plus Z sub alpha over 2 times sigma divided by the square root of n. I have my formula and I have all the substituting values for the key components of the formula. So I'm going to plug in. I've got 1.21 minus 1.645 times sigma is 0.65 divided by the square root of 1120 is less than mu is less than 1.21 plus 1.645 times 0.65 divided by the square root of 1120. Alright, we're going to put this in our calculator. Okay, in our graphing calculator, we're going to enter 1.21 minus 1.645 times 0.65 divided by the square root of 1120. Enter. Based on the summary statistics being rounded 2 decimal places, we want to round our lower boundary and upper boundary for our confidence intervals the same way. Now when you're working on the MyMathLab program, just make sure that you follow the directions that are given. So if I round this 2 decimal places, I'll get 1.18. So I have 1.18 hours as my lower bound on the confidence interval. Okay, enter the other side. Now, the only difference here in the right and left is the minus and plus. To save time in typing this in, I'm going to hit second, enter. That pulls up the last thing that I entered. Go to the minus sign and replace it with a plus and enter. 1.24. 1.24 hours. Right, in the problem, we were asked to construct and interpret the confidence interval. The interpretation is a very important part of the process. You may not be asked to interpret these problems in as much detail on the MyMathLab program as we are going to do here, but you will be asked to do this type of interpretation on your final exam. Alright, for our interpretation, I can say we can be 90% confident that and I'm going to take the words of the problem from here to here, that the mean amount of time spent eating or drinking each day by Americans 15 years of age or older is between 1.18 and 1.24 hours. When we have a problem that says interpret in the context of the problem, this is exactly what it means, using the words of the problem to explain the solution. Okay, so we can be 90% confident that the mean amount of time spent eating or drinking each day by Americans 15 years of age or older is between 1.18 and 1.24 hours.